You are welcome once again to Eko Learners Support for WAEC and NECO candidates. And today we will continue our journey of geometry. Don't forget we have looked at lines and angles. We have also looked at the first aspect of geometry, where we considered some basic theorems like double angle. So today we want to move from there and see some of the those things that we'll get after based on double theorem or double angle. There are also some other theorems that we can get from that. So once again, I remain Kamaldin Abiola.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
We want to look at apply other chord theorems in solving problems and apply the theorems of cyclic quadrilaterals. So let's move on. Don't forget, before we have mentioned isosceles triangle, the fact. So we also need the fact here. Okay. So apart from the fact, we also need the second fact too, which is about chord. All right. So, and we have also looked at the theorem on double angle. So don't forget that particular theorem. So this is just a recap of those things that we have mentioned in the last video. Okay. So today we want to move to segment angles. So angles in the same segment are equal. Don't forget, the last time we looked at double angle theorem, and in that case we said this, okay, the angle, this particular arc subtends at the center, this angle is subtend at the center, is twice that is subtends at any point on the remaining part of the circumference. I can pick this point, for example. So it means whatever I have here is twice of this. So since this is 30 degrees, it means this is 60 degrees. I may also decide not to use this particular point. The theorem says at any point on the remaining part of the circumference. And don't forget, this is the arc, and the remaining part of circumference are all the black areas. So we can pick any point. So I can come here to pick this. If I come here to pick this, then it means the angle at the center is also twice this. So this is also 30 degrees. So I can pick another one here and bring a line here, bring another line here. This is also what? 30 degrees. Now, in this particular theorem about segments, this segment, angles in the same segment. How do you recognize angles in the same segment? Now, look at this. The end of this chord, or the end of this arc here, and the end of this arc. Let's assume that we have a chord here. It means this is a segment. So the angle produced by this particular segment, this is an angle produced by this segment, because the two legs that make up this angle, the two legs are coming from the end of this segment. If you look at these two, the two legs, the lines that form an angle, we call them legs of an angle. We also call them that. So these two legs are also from the same place. So that is 30 degrees. The same thing here, the two legs that form this are also from the same point. So as a result, when we have angles and the two legs that form those angles are from the same place, they pitch their legs at the same point to form the angles. In that case, we say that those angles are angles in the same segment. So it means this angle 30 here, angle 30 here, angle 30 here, they are angles in the same segment. And from what we have seen, angles in the same segment are equal. So that is what we can get from this. Angles in the same segment are equal. Okay? So we also have another theorem, which is also based on that same double angle. Remember that when we did double angle, we said angle at the center, that an arc form at the center is twice that it formed at any point on the remaining part of the circumference. Do you remember? Yes. We can apply that here too. So it means some of the theorems we are doing now, they are just consequence of the double angle theorem. All right. So in this case, this is the center. You know, we have this arc now. This is a special arc. It's a special arc because it's covering the middle. It's covering half of what? Half of a circle. So this particular arc produces angle 180 at the center. 180. So if it produces angle 180 at the center, it means that because it's a straight line, so it is 180 degrees. So it's twice that it subtends at any point on the circumference. So it means directly we see that this is 90 degrees. So, and that's why we have the theorem as the angle in a semicircle is a right angle. Yes, it must be. Since this is 180, then this must be 90 degrees, half of 180. So that is what the theorem is also talking about. Let's move. We also have another one, which is cyclic quadrilateral. The word cyclic, circular, quadrilateral. Quadrilaterals, what are quadrilaterals? They are four-sided figures. So we have a four-sided figure inscribed in what? In a circle. It's what we call a cyclic quadrilateral. So this is a cyclic quadrilateral. And from what we have got in a cyclic quadrilateral, says the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. How do we get opposite angle? This is an angle here. If you label it A, B, C, D, then A and B, you can see they are by side. We can say they are adjacent. But these and these are opposites. So these are opposite angles of a cyclic quadrilateral. And these are opposite angle of a cyclic quadrilateral. So we say A and C are opposite angle of a cyclic quadrilateral. And when you add the angle together, it must give us 180 degrees. You also had this. Do you believe that this is also a consequence of the double angle theorem? Okay, let's try that. You remember, this is the center. This is the center. Let's assume we have this and we have this. From what we have done before, if this is 80, that is the circumference. This is the center of it. So if this is 80, it means this is what? Twice of 80. Do you remember? So as a result, 80 times 2 will give us what? 160. This is 160 degrees. The same thing. This is 100. This is at the circumference. And this is the center of it. The one that is what? Related to this. And since this one is what? Since this is 100. Since this is 100, it means this should be what? Half of 100 or times. Because this is center. And this is what? Circumference. So circumference or center is twice the circumference. So if this is 100, then this is what? 200. So can you get that from that? Get something from that? If you add everything together, it will give you 360 degrees. That is why mathematics is always true. So that is what we can get from there. So far we have been able to look at 5 basic theorems. Double angle theorem. We have been able to look at semicircle theorem. We have been able to look at segment angles. And we have also been able to look at cyclic quadrilateral. So it means we should be able to solve problems based on this. Let me recap again. The angle at the center is twice the one at the circumference. The angle in a semicircle is 90 degrees. It's right angle, that is 90 degrees. And at the same time, segment, angles in the same segment are equal. Then for cyclic quadrilateral, opposite angle of a cyclic quadrilateral are supplementary. And that's another way you can see it in another textbook. They are supplementary. And in mathematics, when we say supplementary, it means they add up to give us 180 degree. So let's move. We have some questions. Okay, this is related to what let's just recap this. Center is twice the circumference. So 84 is twice x, which we have done earlier. We solved this in our last class. Okay, so this, okay, so let's take a look at this also. This is 42. So from isosceles, 42, this will also be 42. And we look for the value of x. So what is x? 42, 42, that's 84. They add up to give us 180 degrees. Sum of angles in what? In a triangle. Alright, so, and this will give us 96. From 96, we get the value of y. And the value of y will give us this divided by 2. And that is 48. Don't forget. The same thing with this. Let's look at this together here. This is 62. The one at the what? At the circumference is 62. And the one at the center here is P. So from what we have learned, it means P at the center, P is twice 2 multiplied by 62. And that is 124 degrees. So P is 124. If P is 124, don't forget this is Q, this is isosceles. They are equal. And if this is Q, this is also Q. And in that case, to get this, we have 180. So we have P, which is 124, plus Q. We make up what? 180 degrees, because there are sum of angles in a triangle. Alright, so we have 2Q equals 180 minus 124. And that is what? That is 2Q equals 56. So when you divide both sides by 2, we have Q equals 28 degrees. So that's the solution to that. Okay, so we have done that. Okay, so for semicircle, let's quickly look at a question on that. Okay, so we have done this. Angle in a semicircle is a right angle. Angle in a semicircle is a right angle, and this is the question. So this is a diameter, then this must be 90 degrees. We have done this. Okay, so this is just illustrating that. Okay, so this is an example. Find the unknown. We have angle A, B, C, D, and E. They are unknown. So how do we get that? Okay, so let's take it one after the other. This is A. This is A here. Okay, we have 30 degrees here. We have C. Okay. All right, this is O. So it means this is O, center O here. Okay. So if you have center O, it means this line is what? Is a diameter. And when you have a diameter from this particular theorem, this is 90 degrees. It means A is 90 degrees because A is angle in a semicircle. The angle in a semicircle is a right angle. So this is angle in a semicircle. This is also angle in a semicircle. Because they are facing, look at it, this is a diameter. So A is 90, B is 90. A is 90, B is 90. All right. So I'm going to semicircle. Okay. So let's look at other ones. C. How do we get C? If you pick this triangle, it's a right angle triangle. And the sum of angles will give us 180 degrees. This is 90. It means the two are complementary. Remember that? Complementary angles, they are angles that add up to give us 90. Since this is 90, so the remaining two are complementary. So add up to give us, so it means C plus 70 equals what? 180 degrees. So C is 110. Okay. So from there you can find D. You can find D. Okay. So C is, now how do we get D? D is also angle in the same segment. So that is 90. Okay? And E, the whole of this angle. So it means you bring out this triangle. If you bring out this triangle, this is 30. We know this as 90. And the two angles are also complementary. They add up to give us 90. So if this is 30, then E is 60. Okay? So let's... Okay, so we have also looked at this, which is, let's quickly take a question on that. Okay. So they are all equal angle in the same segment. So we have a question here. Yes, these are the questions. Okay, so angle in the same segment. Find the angles. You can see they are all in the same segment because they have their legs at the same place. The legs of 38 from here, the legs of X is here, the legs of Y is here. So they are all equal. They are all 38. The same thing come here. The leg of Y, the legs are from here and here. They are here and here. So which is the same place that 40 pitch is leg. So Y is same thing as 40. Okay, the same thing. Look at the legs of 30. The legs are from here and here. The legs of angle X are also from here and here. So they are also what? Equal. So X equals 30 degrees. So that is okay. So we look at the practice question. Okay. Have a question here, and from the diagram I've been given angle 63 degree, and I've been given, this is how far. Okay, I think another thing that I've also been given that is not indicated here is this and this are equal. Yes, they are equal. This and this are equal. So the question is find alpha and beta. This is alpha and this is beta. So find the value of alpha and beta. I give you just 30 seconds. Okay, let me give you 60 seconds for that. So take 60 seconds to do that. You are welcome back. I hope you got that right. All right, okay, so let's look at it together. Yes, don't forget I provided an additional information here, which is this and this are equal. Now let's look at this together. This is the center. Okay, so meaning that this is the diameter. If this is diameter, then think of what? Angle in a semicircle. So this must be 90. Okay, so if that is 90, okay, so if that is 90, what happened? Then we also have this. This is a four-sided figure. This is a four-sided figure. So if this is a four-sided figure, that's cyclic quadrilateral. Cyclic quadrilateral. So in such a case, we have the sum of opposite angle of a cyclic quadrilateral are what? Are supplementary. They add up to give us 180. So as a result, we have alpha plus 63 degree equals to 180 degrees. So alpha equals 180 minus 63. And that is what? 117. 117, is that right? Yes. So it is equals to 117. And the question also say find beta. In fact, we don't even need, that's just it. Sometimes they give us extra information that we don't need. And that is that information. We don't actually need it in this case. So this is, now this is another triangle. This is a right angle triangle. This is 90 already. And we are looking for beta. So what do we have? We have this and this. We also add up to give us 90. So beta plus 70 plus 63 equals 180 degrees. And beta equals 180 minus what? Minus 63. No, sorry. I mentioned it. That it add up to give us 90. Yes. Because I don't need to use 180 at this time again. Because these two are left. I've removed this 90. So I have equals to 90. Okay. So this should be 90 minus 63. And that is 27 degrees. So beta equals to 27. Alpha equals 117 and beta equals to 27. Don't forget I mentioned that you don't need to actually state that beta plus 90 plus 63 equals to 180. If you state it, no problem. But when you have a right angle triangle, the two other angles are always complementary. And don't forget, complementary angles means they add up to give us 90 degrees. So we can actually say beta plus 63 equals to 90 and beta equals to 27. So thank you very much for listening, for your rapt attention.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Don't forget, if there are questions, comments, you can make use of the link on the screen. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.